What is a triaxial test in soil mechanics? In the world of geotechnical engineering, understanding how soil behaves under stress is crucial. While surface-level observations might tell us the type or color of the soil, they don't reveal how it will perform under heavy loads or during an earthquake. That's where the triaxial test comes in. It's one of the most advanced and informative soil mechanics tests used today, providing engineers with a deep understanding of soil strength, stability, and deformation behavior under controlled conditions. Purpose of the triaxial test. The main goal of the triaxial test is to determine the shear strength of soil. Shear strength is the soil's resistance to sliding or failing when stressed. Unlike simpler tests, the triaxial test simulates real-world stress environments where soils are subjected to both vertical and horizontal forces. This makes it particularly useful for analyzing slope stability, designing retaining walls, evaluating foundation systems, and assessing earthquake resistance. How the triaxial test works. A cylindrical soil sample, usually about 76 millimeters in height and 38 millimeters in diameter, is carefully prepared and placed inside a rubber membrane. The sample is then positioned in a pressure chamber filled with fluid. This chamber allows engineers to apply uniform pressure from all sides, simulating the natural pressure soil experiences underground. Once the cell pressure is applied, axial stress is gradually increased from the top until the soil sample fails. Throughout the test, measurements are taken for stress, strain, and pore water pressure. Different types of triaxial tests. There are three main variations of the triaxial test, each used for different conditions. Unconsolidated undrained (UU) test. In this test, the soil sample is not allowed to drain or consolidate before the axial stress is applied. It is quick and used for short-term stability assessments, like in emergency or temporary works. Consolidated undrained (CU) test. The sample is allowed to consolidate under pressure before being loaded. Drainage is not permitted during loading, but pore water pressures are measured. This gives both total and effective stress parameters, useful for both short and long-term analyses. Consolidated drained (CD) test. The sample is fully consolidated and drainage is allowed throughout the test. It takes longer to perform but provides very accurate effective stress data, ideal for long-term loading scenarios such as foundations and embankments. Why measure pore water pressure? One of the key advantages of the triaxial test is its ability to measure pore water pressure, something most other tests can't do. Pore water pressure affects the effective stress in soil, which in turn determines how strong or weak the soil actually is. During events like rainfall or earthquakes, pore pressures can change rapidly, making the soil more prone to failure. By monitoring these changes in a controlled environment, engineers can better predict real-world behavior and avoid disasters. Stress-strain relationships and soil behavior. The triaxial test also helps engineers understand the stress-strain relationship of soils. Some soils show brittle failure, sudden cracking, and collapse, while others show ductile behavior, deforming significantly before failing. Knowing this behavior is important when designing structures that need to withstand long-term loads or dynamic conditions. The test also reveals critical values like cohesion and the angle of internal friction, which are essential parameters for designing safe and stable earthworks. Applications in civil engineering. The data from triaxial testing is used across many areas of civil engineering. Slope stability. Engineers use it to assess whether a slope will fail under certain conditions, such as after heavy rainfall. Retaining structures. It helps determine the earth pressure exerted behind retaining walls. Foundation design. Triaxial test data ensures that foundations can handle both vertical loads and lateral movements. Seismic design. It provides insights into how soils will respond to earthquake forces, especially in saturated or loose conditions. Limitations and considerations. Despite its value, the triaxial test is not without limitations. It requires careful sample preparation and takes time to conduct, especially for the drain version. The results can also be affected by soil disturbance or improper saturation. Engineers must interpret results cautiously, combining them with other field and lab data for a comprehensive understanding of site conditions. Final thoughts. The triaxial test is a cornerstone of modern soil mechanics. It transforms a simple cylinder of soil into a window into the ground's mechanical behavior. By simulating real-world pressures and measuring critical stress responses, it empowers engineers to design safer, stronger, and more reliable structures, whether they're building on a hillside, a floodplain, or the heart of a city. Thanks for joining Blueprint to Reality. If you enjoyed exploring the depths of soil behavior, don't forget to like, share, and subscribe for more in-depth civil engineering breakdowns. Keep building with knowledge.